Okay, we're going to start by going over a couple examples from section 8.4 on simplifying fractions. These aren't just any fractions, these are algebraic fractions. And to go over the steps here, let me start here on our reference sheet for simplifying fractions. In simplifying fractions, you're going to start off by factoring both the numerator and the denominator. So you need to factor both numerator and denominator. And once you have those factored, the next step's very easy. All you're going to do is cancel common factors, one from the numerator with one from the denominator. Okay, so let's say if you had 2 times 3 over 2 times 5, common factor here would be a 2, which would leave you with a 3 over 5. Okay, that's pretty simple from elementary school. The ones we're going to be doing are going to be a little bit more complicated than that. Then the final step, you just rewrite your simplified fraction. Okay, and the hardest part of this process is going to be, of course, the factoring. And I'm going to refer you on your reference sheet to the different types of factoring. First of all, you have the greatest common factor. So as we look at the common factor, you would look at each term and see is there anything in common. And here, this has an a and an x, and this term has an a and an x. Therefore, we'd be able to take an a and an x out of both terms here. And when you pull an a and an x out of the first term, you're left with an x. When you take an a and an x out of the second term, you are left with a 1. Okay, and then you're left, if that doesn't factor using greatest common factor, or if even it does, you'd be left with one of two possibilities, and you have to look to decide if you have 2 terms or 3 terms. If you have 2 terms, you're really looking for a difference of squares, where you're looking for the first and the last term to be perfect squares, and then the sign in between to be subtraction. If you do have that, then these factor into conjugates, and conjugates again are where the first term in each and the last term in each are identical, and the signs are just opposites. This is minus and this is plus. Okay. If difference of squares does not work, then you're going to need to look at doing opposite of FOIL, and that requires 3 terms. And again, the first term is the first term gets you the first terms here. The last term gets you the last term here, and then the outers and the inners terms, those get you the middle term. Okay, so that's the FOIL process. Okay. So let's look at a couple here to begin with. We'll look at a couple in this one, and then we'll follow it up with a couple more in the second video here. So starting off with a real simple fraction here. If you don't have any plus or minus signs in the problem, then we know that there's no factoring involved. We're just going to go ahead and cancel. So on this one, you notice that we have a 3 and a 6. Well, 3/6 reduces down to 1/2. And then as far as the x's go, we have 2 x's on top and 1 x on the bottom. And you can kind of think of that as 2 x's here, 2 x's here, and you can cancel one of the sets. So when you do that, this x cancels with one of those, which leaves you with an x on the top. And then the same thing happens with the y's. You have 3 on top, 2 on the bottom, so the 2 on the bottom cancels with the 1 on the top. And once you have those all canceled, you would just rewrite what's left. So on the top you have a 1, you have an x, and you have a y, and the only thing left we have on the bottom is that 2. Okay, so this would be your final simplified fraction on the first problem. Okay, on the second problem, we have plus and minus signs in here, so we know we're going to have to do some factoring. And remember, you always check for greatest common factor first. So we're looking for a common factor for 2x and an 8. So 2 and 8 looks like there's a common factor of 2, so we're going to write the 2 out in front, which leaves you with something plus something. And now we got to figure out what are the 2 things 2 needs to get multiplied by to turn it into those 2 terms. Well, the 2 would need to be multiplied obviously by the x there, and then the 2 would need to multiply by a 4 in order to get you an 8. Okay. You can think of this type of factoring as called undistributing. because this here, the 2 is already distributed through to both terms, and now we're taking it back out. So you can think of that as undistributing. That's what I like to call it. And on the bottom here, we look to see if there's a greatest common factor. And the first term only has a 1, so there's going to be no common factor for the 1 and the 6 other than 1. And then we look to see if there's an x in both, and there is not. So therefore, it can't be a greatest common factor. So then, again, we come to our reference sheet here, and our only options if greatest common factor doesn't work is either 2 terms or 3 terms, and this one only had 2, so it must be a difference of squares. If it's not a difference of squares, then it must not factor. So in a difference of squares, we're looking for a perfect square here and a perfect square here. And it looks like we have that. We have an x times itself, and 16 would be 4 times itself, so those are both perfect squares, and the sign in between is subtraction. And remember that difference of squares factors into what we call conjugates, which means the first term in each has to be the same, and in this case has to get you x squared, so that has to be x and x. The last term in each has to be the same, and it has to get you the last term here, which is 16. So that must be a 4 and a 4. And then because they're conjugates, we know there's 1 plus and 1 minus. And the reason why there's only 2 terms here is because if you check your outers and your inner terms here, you get a positive 4x and a negative 4x for your outers and your inners, and those would cancel. So this does get you x squared minus 16 when you multiply it back out. And now you'll notice that something very nice happens. We do have a common factor here on the top and bottom. This is x plus 4 and x plus 4, which then gives you your final fraction of 2 over x minus 4. And recall that you cannot cancel the 2 and the 4 here, because this 4 is really, I like to call, glued together with the x. Anything that's added or subtracted onto each other, you can kind of think of those as being glued together. Okay, we're going to stop there on this one, and we're going to pick up in the next video with problems 3 through 5.